Welcome to the Modern Medicine Movement Podcast. Super pumped, super grateful, excited to be here with you once again for another power-packed episode, which will not disappoint. Who's ready? Woo! So we are back. We are here. We are well into summer now. It's the time of activity. We're doing stuff, just having so much fun with the kids at celebrations, at barbecues, playing football, running around, mountain biking, surfing, climbing, hiking, whatever you're doing, running, jogging, walking, my personal favorite. It is a great time for that, at least here in the US of A. The weather is beautiful. I love the summer. It's a perfect time for some vitamin D therapy. You guys have been hearing me share a lot about that lately, which is just one of my favorite vitamins. And, last week's show where we talked about how you got to have magnesium in order to absorb the vitamin D, especially if you're taking it in the diet, food first, remember, or if you're taking it in the form of a supplement, which I often do, especially in the wintertime, because I'm not getting a lot of vitamin D. You actually have to have magnesium in order to be able to fully absorb it and make use of it. So that was a fun show that I did. One of these little tidbits that I really wanted to share, because I think I may have not shared it in the initial podcast I did on vitamin D. I think I was so excited about all the immune benefits and immune health things that I forgot to share that essential piece of information. So welcome to the show this week, guys. Super pumped, super grateful to share a new exciting topic that we've literally only barely scratched the surface of before when we talked about the macronutrients. And today we're just going to get into it. And before we dive in, just full bore, full on, full court press, I just wanted to thank you guys, for being here, for listening, for being part of the team, for being part of this whole movement, our modern medicine movement, which is true, natural, real health through simple, natural ways where we can basically optimize our life, our mind, our body, our soul, all things health, and in a natural way. It's just such an exciting movement. I've gotten a lot of feedback from you guys recently, and I can't wait for more, because I think you may have heard I'm going to be giving away one of my courses. It's a $197 course on natural health, natural weight loss, and I'm basically going to draw out of a hat all you guys that do a review that I can see on Apple Podcasts, or if you do it elsewhere, take a screenshot of it and email it to me, because I'm only seeing those readily on Apple, because that's just the platform that I personally have and use for podcasts, and that's the most widespread. I think like 90% of all you guys happen to listen on Apple Podcasts. So I would just plead with you to please write a review, tell me what you're loving, and you'll get a chance of winning a free course, $200 value. You get my course for free. So please write a review. I can't wait to see it. I love those things. They tickle my heart. I read every single one of them. So please write a review. Super easy to find at the end of when you click on my show at the bottom, you see those 5 stars. Just click on the one farthest to the right, and then the little button right below it on the left, it looks like a little square with the pencil coming out the top, and it says write a review. And then just type me a sentence or two and tell me what you're loving, what you're learning, all that good stuff, because that's just one of the big reasons I keep coming back. And I just can't wait to do this each and every week, because I just enjoy it. I just think of you guys out there learning and growing and sharing and just optimizing your health, living better, more full of energy and vitality. And that just keeps me doing this. And this week, the show is no exception. We're going to talk about one of the things we can do to increase vitality, to increase our energy, to increase our metabolic rate, to be able to also, even if you want to, you can lose weight by optimizing this strategy. And this strategy is none other than one of my favorite macronutrients, that of protein. And I think this may be a little bit of the redheaded stepchild, because maybe second only to the fats, which have been certainly misconstrued over the years, with all the dogma on the low-fat diet, which is a bunch of hogwash, not based on data and really hurt a lot of people, millions of people, because we necessarily, when we limited fat, we increased the sinister, well, not really sinister, but we increased the macronutrient way too much of carbohydrates, which cause insulin to go up and make us fat primarily. Fat typically does not make you fat, especially when you're eating high quality natural fat, and protein also does not typically make you fat, whereas glucose and carbohydrates absolutely make us fat. So we're going to talk all about protein today, my favorite macronutrient of the week. And it's just one of those cool things because there's so much research, so much data on protein out there. And it's been also the target of some, not awesome press, because these quote unquote epidemiological studies that have been shared over the years that have not been well done have shared a lot of misinformation. So we'll get into that later. But first, let's just talk about what the heck are proteins. Well, I think most of us know that we are protein. Like, we are made up of protein. Literally every single cell in our bodies is full of protein, whether it's a muscle cell, which is primarily protein, or even an immune cell or a red blood cell. Any cell in our body has protein in it. That thing that holds the hemoglobin, that transports oxygen in our blood, that gives us that vitality, the breath of life, so to speak, would not be possible without the hemoglobin protein, that iron in the center of it and how it can bind to oxygen. Like, we couldn't even breathe without protein. So protein is that important. It's literally in every single cell of our body, not just in the stuff we often think about, which is, our muscles and our bones and our connective tissue, our skin. We all know that that's made up of protein, but literally each and every cell is made up of proteins. And even when you don't think about it, every cell has these things called enzymes. Enzymes are what basically allow all these reactions to occur in our body that keep us alive. All of these chemical reactions that occur, remember how magnesium is responsible as a cofactor, and these exact enzymes that I'm talking about, which are made of protein, and 600 plus of these reactions, magnesium is responsible for being a cofactor. Zinc, which I think I'm going to be talking about next week, is also an important cofactor. And these enzymes, which catalyze or make occur these reactions that keep us living, that keep us alive. And all of these enzymes are, you guessed it, they are made of protein. So super, super important that we talk about protein. And I guess this has got a really sort of special place in my heart, because I'm at the place where, most people would call it sort of midlife. I'm approaching 50, and the path of least resistance in my stage of life is that we actually lose our main protein area, which is our muscle. We tend to lose that as we age, and that's not a good thing. And all the studies exactly show that that is not a good thing. As we lose our muscle mass, or this phenomenon called sarcopenia, age-related sarcopenia, which just means loss of muscle mass as you get older. Although it's super, super, super common, let me tell you, this is not a sentence. This is not a must. This is not something that has to occur, but it is certainly, unfortunately, the path of least resistance. So if we do not exercise, if we do not eat protein and attempt to keep our protein, keep our muscle mass, it will go away. And I've seen that all too commonly in folks as they age. They get thinner with respect to their muscle mass, and they lose functions of a lot of things. They have less ability to do things, to walk, to run, to lift, to move, to even get up out of a chair. You got to have muscle mass to do that. And so we're going to talk about how we can keep our muscle mass. And a lot of it's through taking in this important macronutrient of protein. And of course, exercise is important as well, because we want to prevent this age-related sarcopenia. But before we get into that, let's talk just a little bit about the basics of protein. And I've sort of briefly expounded that it's in every cell of our body. And what's more important is often we don't think about this, but protein is considered an essential macronutrient, an essential nutrient, and it is one of the 3 macronutrients. And the reason I say essential is because we don't really have an acceptable sort of storage form in the body where we can just dip into to be able to provide our body with the essential building blocks, or these amino acids which make up all the proteins that we have in our body. Because what happens is that we can sometimes dip into our muscle mass, but that's typically not a good thing. We'd rather not dip into our muscle mass. It's not an expendable storage form like we have for glucose, for example. We have muscle glycogen, we have liver glycogen, also fat. We got lots of that, right? Some people call that the life preserver around the middle, the midsection that sort of gets us through times of famine. That's how it was originally described, but we got lots of fat. The storage form is readily available for fat, as well as the glucose or the carbohydrates, which is that glycogen, the muscle and the liver glycogen. But we actually don't have a good storage form for protein. We actually don't have one. In fact, that's why it's called essential, because literally we must eat it each and every day, because if we don't, we're going to be breaking down our muscle tissue to feed those requirements that we have for just daily maintenance of producing the appropriate enzymes that we need for our bodily functions, because they come from amino acids, which come from the breakdown of protein. So let's make sure we eat enough protein, because we literally need it each and every day. And that cannot be said for fat and glucose or carbohydrates, because we do have a storage form for both of those. So we could go without those for a long period of time, and it's not a big deal. We will survive just fine. Our body can certainly make, all the glucose that we need through a process called gluconeogenesis. We've talked about that ad nauseum. And then all of us, including me, have plenty of fat to keep us going for quite a while. But protein is one of those things that we must have, which is why I don't particularly, at least in myself, I don't do long periods of fasting. I think once in a while is fine, but just like a daily short fast, sort of this intermittent fasting or time-restricted eating is cool and important, because it does a lot of cool things for decreasing inflammation and helping to improve longevity. We'll talk about this, but we must couple that with appropriate and sufficient protein included in our diet, because if we don't, then we start to break down muscle tissue, which is not an awesome thing. So we'll get all into that. But when we talk about protein, I think it's important to talk about, let's just talk about firstly, what's this notion of essential versus non-essential? So protein is basically made up of these smaller units called amino acids. And I think these have gotten a little bit more popular, these so-called branch chain amino acids, which are popular in certain industries and health industries and things like that. And that's super important to consider. But really, when you think about protein, it's basically made up of these building blocks. They're called amino acids. And there's 22 of them. I know the old research showed 20, but there's 2 more that have been discovered. And you guys are getting the state of the art, hot off the press. So there are 22 known human amino acids. When you consider all the other organisms out there, there's way more than 22. But in humans, there's 22, and 9 of them are considered essential, which means that we actually can't make them ourselves. We have to get them from the diet. These would be important ones such as leucine and lysine, and we'll talk about those in a little bit more later. But the reason we need these things is because we actually can't make them. So that's why I was telling you that protein is essential. We actually got to get it from the diet, especially these essential amino acids, because we cannot make them. And so when you hear the word quote unquote complete protein, it's often referring to exactly that. It's referring to an amino acid, a protein that has all of the 9 essential amino acids in it. This would be something like red meat or milk, that contain all of these essential amino acids, and they are considered complete protein. So we'll get into that in a little bit, but I want you guys to think about as well that in order to not only survive, but thrive, which is what we're all hoping to do, we got to have adequate protein intake. And so I would say a bare minimum would be between 1 and 2 grams per kilogram of ideal body weight. So let's just take my case, for example. I'm about 150 pounds. This translates to about 70 kilograms. So I'm going to need between 70 and 140 grams of protein each and every day to maintain my function, maintain my muscle mass. And then if I'm trying to build muscle mass, which actually right now I'm actually trying to do because I feel like I'm losing it as I age, I got to even have more than that. So maybe somewhere between 2 and even 3 grams of protein per kilogram ideal body weight each day. So this is something that each of you can sort of experiment with. It's something that you have to individualize and personalize based on your own scenario, because it's not one size fits all. Some of us have different goals. Some of us are trying to bulk up, others just maintain. And so it's going to be anywhere between 1 and 3 grams per kilo per day of lean body mass. But just remember, as we age, the process of least resistance is such that we lose muscle mass over time, which is not a good thing. This is called sarcopenia. Anyway, we must have protein in our diet. We just really, really need it because it provides those essential amino acids that we are made up of, and we just can't get it any other way. We need to get it in from the diet. So another cool part about protein, besides the fact that it's just a must and it's essential, is that it can actually help us with things like weight loss if we desire to lose weight. Lots of studies have shown that high protein diets are helpful and beneficial for weight loss. And there's a couple of reasons for that. One is that protein is much more energy dense, much more satiating. And in fact, there's this kind of cool phenomenon out there called the thermogenic effect of food, or the thermic effect of food, which is basically each, let's say, macronutrient like protein, glucose, or carbohydrate, and fats, each of those 3 macronutrients has a certain thermogenic effect. And protein has the highest one, which means that it produces, or I should say requires the most amount of energy to be able to break down the protein that we eat, thus burning more energy or increasing the metabolic rate higher and more so than both fat and more so than carbohydrates. So in that way, if you eat more protein, you're actually going to burn more fat, so to speak. Isn't that cool? So eating protein will contribute to your fat burn through this thermogenic effect of food. And this has been shown in the literature. There was a cool study in the Journal of the American College of Nutrition that showed that protein has a much higher thermogenic effect of food than does carbohydrates, than does fats, up to 2 or 3 times higher, and can lead to weight loss. The other cool thing is that I mentioned a little earlier is that it can cause satiety, which is, if you're trying to lose weight, a good thing. Like especially in the morning, if you start your day with protein, like I do. I eat 4 eggs like basically every single morning, sometimes even more than that, sometimes a couple less than that. But I eat on average about 4 eggs every morning because they're full of protein, which is an awesome way to start your day. So it'll cause some satiety. It'll make you want to eat less in that meal and throughout the day. It'll make you kind of more, feeling good, feeling full. You don't get that 2-3 hour postprandial, after eating crash that you get when you eat carbs. If you start your breakfast or first meal of the day with, some cereal and some toast and a croissant and a bagel and things like that, you're loading up with the carbs and you're going to be crashing 2 to 3 hours later. And if you start with protein, that is not the case. You're going to feel more full, more satiated. You're going to have a more higher, metabolic rate through this thermogenic effect of food. And the studies actually show that for whatever reason, when you eat protein in the morning and start your day off that way, this even has a more pronounced effect than if you just simply ate protein at every meal, which I also recommend, but I would do a higher sort of percentage of protein in your first meal of the day and make that a super low carb meal, because actually the worst time of the day is to eat carbohydrates would be at breakfast or in the morning. And I've talked about that before, so I won't get into that, but basically there's this little thing called the morning rise in your stress hormone called cortisol, and it makes you insulin resistant in the morning. And so if you put carbohydrates on top of that, it even worsens the insulin resistance, and it's going to make those carbs go right to your midsection, right to your fat. So you don't want to be eating carbs in the morning. That's the worst time to eat them. If you do eat carbs, be like me and like I'm going to do tonight for my daughter's birthday. She likes pasta. We're going to have pasta tonight. We're having it in the evening, which is the best time to eat carbs. Anyway, so now that you know that protein is required, it's essential, it's important, it's beneficial. So where the heck do you get protein? Well, you get it from plant food, you get it from animal, you get it from both. Protein is in both plant and animal foods. What's interesting is that, and shouldn't be surprising, I guess, is that our bodies, given we are animals, right? We're in the animal kingdom. We're not in the plant kingdom. And so we can use, digest, assimilate the amino acids from animal protein way better than we can from plant protein. And this is not to say that we shouldn't eat both. I personally eat plant protein, I eat animal protein, I do both, and they both have their place. But just to report the actual science and data, we are, as not surprisingly, we are animals, and so we can process, we can digest, we can use and assimilate the amino acids found in animal proteins a little bit easier than we can from plants. And there's this whole thing, which is a little bit complicated. It sounds pretty intimidating. It's called the PDCAA, and this is basically the digestibility of protein. And it sounds pretty complex. It's called the protein digestibility corrected amino acid score, or the PDCAA. And what it is it's an attempt to be able to describe numerically with numbers how well we can digest a certain kind of protein. And sort of the perfect case would be like the 100% or a N equals 1, where we can basically digest that protein no problem. This came about from the Food and Agricultural Organization as well as the WHO. I think they came up with this in like 1993 or something like that. And it was just to provide some kind of a benchmark as to how we can rate protein and how well we can absorb it as humans and how well we can use it in our bodies to make new proteins. And so, like I said, sort of the perfect protein out there in this respect when referring to this PDCAA, this protein digestibility corrected amino acid score, which I don't recommend you memorize, but just kind of know that sort of because we're animals, we can digest animal food better, that the animal proteins, and this has been studied and detailed in the literature. I'm not just making this up because I eat both plant and animal, but sort of the perfect human protein is an animal protein because that's what we are. That's what we're made of. Protein begats, protein like begats like. And so sort of animal proteins such as milk, cow's milk, goat milk, whatever kind of milk, eggs as well. Whey protein are given a value of 1 or 100% availability, whereas something like, for example, let's go down the list, like cereals and other derivatives, quinoa, things like that have a 0.59 or about a 60% digestibility. Rice is down to about a 50% digestibility. Wheat down to 40%, gluten down to 25%. So this just means that we can still get protein from these other sources, but it's just going to be a lot less available to us, and we're going to have to eat a lot more of it to get the same quantity of protein, which is one caveat I would sort of mention, that if you're only getting your protein from plants, that's okay. You can get enough from plants typically, but you're going to end up eating a lot more carbohydrates. So make sure you're getting them from well-sourced, natural plant, food first, I should say, or high quality, if you must supplement, high quality plant protein first, and try to not be getting it from these processed foods and the like, because you're going to be eating tons of carbs, not getting as much protein as you want, and then you're going to have a carbohydrate problem, which is not awesome. So that's what this whole notion of the PDCAA, protein digestibility corrected amino acid score is. It's just an attempt to rate how well your body can break down and absorb the protein, okay? So where do we get this protein? Well, I already mentioned things like eggs and meat, red meat, chicken, turkey, fish, shellfish. These are all sort of animal sources of protein, and they're pretty good. They tend to be, at least the red meat tends to be a complete source of protein. It has all the 9 essential amino acids. Chicken, turkey, shellfish are a little bit farther down the list and are less dense than red meat, but they still have lots of these good essential proteins in them. And then you have things like in the plant kingdom that are awesome, like chia seeds, pumpkin seeds, flax, sunflower seeds, grains such as quinoa, millet, barley, spelt, oats, beans, of course, are in there. Vegetables like broccoli and Brussels sprouts. Also, the nuts are a great plant-based source of protein, things like peanuts and almonds, for example. I mentioned the legumes, the kidney beans, chickpeas, of course, soy and lentils. Just make sure if you're eating soy that you're getting high-quality, non-GMO soy, because soy is like corn nowadays, man. It's just being produced like crazy, and a lot of it's not good quality. But you can definitely get protein from there. Just make sure it's good quality. And the same would go with any kind of meat. I talked about this in an entire podcast when I talked about regenerative agriculture, and this goes for red meat, chicken, turkey, it always should be wild, free range, grass fed, sort of a species appropriate diet. Same thing with fish, wild caught, not just in a, pond that's in a factory, factory farm fish I'm not a fan of. You want it from the environment where it's wild and has the best mix of these essential amino acids and lowest percentage of other garbage in there, because we all know that at those feedlots, they ain't feeding those, they ain't feeding those cows grass. They're feeding them oats and grain and all kinds of canola oil and sprinkles and all kinds of garbage. So we want to have well-sourced plant and animal food no matter what. Super important. And in order to get that, we got to go hopefully local, fresh, the places where we can get well-sourced foods, okay? And I'm not going to super belabor that because I've talked about it in other podcasts, but, there are definitely lots of good sources out there where we can get these high-quality proteins. And sort of some of my favorite ones, are, as I mentioned, fish, and I like a good steak. I like kind of all these animal, plus I like a lot of plant proteins, things, for example, like nuts. I love nuts. I love chia. I like some good edamame, which is soy. Hopefully I can always find a non-GMO version because I love to cook those things. I boil them, I spice them, and they're awesome. I also personally, I don't have a problem with dairy. I can digest it just fine. So I love cheese. I don't know if I could live without it. I eat eggs, as you guys know. I rarely eat chicken just because I have a hard time sourcing that well. At least where we are in Hawaii, most of the time, super hard to get well-sourced chicken unless I'm going out and I'm tackling the rooster. Like I had one of my brother-in-law, his mother-in-law was over at the house, and she knows how to do that. She's from Peru, and she saw all these wandering roosters in the yard, and she wanted to literally choke them out and pluck the feathers and cook them up for dinner because she just knows how to do that. And if we did, that would be a much higher quality because those guys are grass-fed. They're just running around eating the plants in the yard. So anyway, I digress. But there's definitely some good plant-based foods out there: quinoa, buckwheat, the nuts that we talked about, lentils, beans, legumes, the soy, the high-quality soy, of course. And then rice and pea protein are a little bit farther down the list, but they're still there. You can get decent protein out there. Just make sure it's well-sourced. And it really just depends on what kind of diet mantra you use. And either one you can get protein from it. Just make sure it is natural, fresh, and it's real food, and it's high quality. One of the things I wanted to talk about just a little bit more, because often we don't think about how, protein can help us in a lot of other ways too, not just because it satiates us and it can help us improve and increase our metabolic rate, but it can do so many other things. In fact, protein through our muscular system, if you will, is responsible for a whole host of sort of, let's call it endocrine reactions. In other words, endocrine is our body sort of signaling, or let's call it the text messaging system of the body, where we communicate all our organs one to another by release of hormones, prohormones, cytokines, and in this case from the muscle cells, myokines. They're basically just hormones released from the muscle that have important effects, which help us to do a lot of cool things. Like one, improve our insulin balance, reduce insulin resistance. Also, we have myokines that can decrease inflammation. And this has been shown. In fact, this first was elucidated in about 2007. So this was well after I finished, a decade after I finished medical school, that we learned about how muscles can be literally endocrine organs, part of this whole messaging system, which is super cool because when you go out there and you exercise, whatever it is, you go for a hearty walk or run or surf, hike, whatever it is, you have the release of myokines, these signaling molecules. The first one described was interleukin 6, IL-6, and it's been shown to be, in the case of acute exercise, anti-inflammatory. In fact, it will help to decrease your risk of heart disease, right? We know exercise is good for us, and one of the ways in which it is good for us is because from the muscle cells, you have these protective sort of chemical signaling molecules called myokines, which are released that are anti-inflammatory. And this interleukin 6 is an example of that because it is inhibitory, or it blocks this bad sort of inflammatory, pro-inflammatory hormone called TNF alpha. And that one's been shown to be involved in chronic inflammation and heart disease and all these things. And so the one released from exercise, no big surprise, actually blocks that or inhibits that and is responsible for decreasing inflammation. One of my favorite beneficial hormones released and promoted during exercise is brain-derived neurotrophic factor, or BDNF. And we talked about this previously because it's how exercise basically makes us smarter. So after you exercise, you can measure this level in the blood to increase, to go up. And what it does is it actually causes your brain to grow, especially this area called the hippocampus, which is responsible for memory and, sort of cognitive thinking and new information processing and learning, memory, et cetera, et cetera. So this hippocampus actually gets buffed up with exercise. You're not only making your legs or arms or lungs, whatever, the musculature there buffed out, but you're actually buffing out your brain. You're getting bigger brains, bigger hippocampi through this brain-derived neurotrophic factor. And it's super cool because this actually goes up with exercise. So lots of benefits there. I mean, if we didn't have enough already, just with our metabolic health, which is improved with exercise, right, through the muscles, we have brain health, which is improved. I mean, how awesome is this? Super, super awesome. So I would highly encourage not only, having a healthy diet with lots of protein in it, but actually also encouraging us each and every day, at least 6 out of 6 is kind of my mantra. And even on the 7th day, I often go for a walk because I just love walking. I love being outside. I love going for a little walk with my family. It's just so much fun. It's so relaxing to be out in nature. And so I tend to do a 6 for 6 of more exhaustive, sort of exertional, sort of this interval, kind of more resistance training. And then on the 7th day, I don't really do any resistance training. I just go for a walk. And that is so good for all these things: decreasing inflammation, improving our metabolism, and making you smarter, making your brain healthier. It's even been shown to decrease signs of chronic brain disease like Parkinson's, Alzheimer's. All these can improve somewhat with exercise and may be prevented to some degree, or it may help with that. So exercise is awesome. What can I say? All right. So I'm getting down to the end of the show here. I wanted to mention something that some of you may have heard about, because sometimes some sources, some media, I won't mention whom or who, but sometimes protein diets, especially high protein diets, are getting a bad rap. And I'd like to say that that's old data. And indeed it is an old news, but sometimes it's still being perpetuated even now, even in the mainstream. And, people are afraid of protein. They think they're going to get cancer because they eat protein. And that is just not the case. That is not the case. In fact, I just performed a review on this of good, high quality data, which is not the epidemiology that I alluded to earlier, which basically was these poor quality studies that showed, oh my gosh, I think protein is showing increased cancer rates and increased death. And those were epidemiological, very super poor quality studies that really did not show that when you go back and relook at the data, but they're not good quality data to begin with. The best is sort of this gold standard that I've taught of before called the randomized control trial. That's where you decide on a hypothesis that you want to test, and then you take 2 groups. You take one, which is sort of the control group, which is just sort of the normal, everyday, whatever group. And then you have the second group called the intervention group, where you do something different. You either increase their protein intake, for example, or give them a new supplement or drug or whatever, and you test it against the control group. So in this particular research study, and I'll try to put it in the show notes for you, this was just out of 2020, so not even a year old. They reviewed 31 of these higher quality studies called randomized controlled trials. And this was reported in probably the gold standard journal out there called the British Medical Journal, or the BMJ, super prestigious medical journal. And it basically summarized 31 different studies with hundreds of thousands of patients and said that high protein diets does not cause cancer, does not cause you to die younger. In fact, it actually improved longevity. It improved it, hot off the press, high protein diet. So beyond just the other benefits we talked about, it can help with weight loss, it can help with promoting muscle growth, development, and hopefully decreasing our risk of losing muscle called sarcopenia. It can actually improve longevity, which was not what we have been told for years because of this dreaded thing called mTOR. Have you guys ever heard about mTOR? It's sort of like what all these folks out there want to poo-poo and say, oh my gosh, you can't eat protein because your mTOR activity goes up and you're going to get cancer. And that's actually not true and not good data that they're reporting. These are crappy epidemiological data. I don't even have time to go into all of that right now, but suffice it to say, the data that is good and high quality that reviews the actual sort of prospective gold standard studies, which are randomized controlled trials, shows that high protein diets is actually good in so many ways. Good for your cardiovascular health. You can lower your blood pressure. You can improve your cholesterol profiles. You can improve your longevity. You can improve your muscle mass. All of these things are good, and they come from high protein diets. So what's this mTOR thing anyway? Well, it's basically mechanistic target of rapamycin is what it stands for, but it's sort of an enzyme complex, and it is turned on anytime there's growth happening in the cell. So this could be muscle growth, fat growth, or even cancer growth. Basically, anytime there's growth happening, this mTOR complex, the mechanistic target of rapamycin. And the reason they call it that is because rapamycin is a drug that binds to it. It binds to this enzyme complex. So they gave it that name because it binds to this complex. So don't let it confuse you. It's not something super exotic and crazy. It's just they found this drug that binds to it. So they say it's the target, the mechanistic target of rapamycin. But basically, it is turned on anytime there's growth happening. So guess what? If you eat protein, you're going to try to grow muscle. There's going to be growth going on. Growth is good if you want to build muscle. Now, the caveat is other things turn on this as well, like too much insulin. So basically, if you're eating carbs, this also gets turned on, okay? So the way that I would interpret this is that you want it turned on when you eat things like protein because you want to build muscle, but you don't want to have this thing on all day long. You want to give it a break because it's been shown that if you have periods of rest where this mTOR activity is decreasing, then that actually helps with longevity. This is like what's been shown in intermittent fasting and calorie restriction, if you will, over these time windows, is that mTOR is turned off because you're not growing. If you're not eating, you're not building muscle, you're not building anything, right? You're taking a break. You're doing that other cool thing that we've talked about called autophagy. So autophagy, that cellular cleanup, that cellular purging, that sort of getting rid of all the toxins, that happens when you're not eating and mTOR is turned off. So it's good to have mTOR turned off for periods of time. In fact, that's why I always promote a window of either intermittent fasting or sort of this, what I like to call circadian fasting, where you're resting at night from eating for 12 to 14 hours, because that period of time, you're doing all the cleanup. You're getting rid of all the damaged cells. mTOR is off, and that is hugely beneficial for both anti-cancer, anti-aging, all these things, because mTOR is off. Now, when you're eating, you're going to eat high-quality foods, and especially high-quality protein. Now that you just learned of the super-duper importance of high-quality protein, you're going to want to turn mTOR on with your meal. And then you're going to take a break, maybe 6 or 8 hours before your next meal. Then mTOR is going to turn off. Then it's going to turn on again briefly when you eat again, because you're eating that high-quality protein meal. And you're able to build that muscle so that you don't get sarcopenia. So does that make sense? mTOR is not necessarily a bad thing. It's just basically showing when you have growth in the cell. And when you have the proper nutrients like high-quality protein, you want to have growth, like muscular growth. You want to prevent this loss of muscle called sarcopenia. But you just don't want the thing turned on all day long, like if you're snacking every 2 to 3 hours, like many times we do if we're addicted to carbohydrates, because carbohydrates cause insulin, to be released. Insulin turns on mTOR. If mTOR is on all the freaking time and never has a break, yes, that has been shown to increase your risk of things like inflammatory illnesses such as cancer. So we do want to have mTOR turned off for prolonged periods of time, like between meals, and this overnight fasting. That's the simplest way to do it. And so you get both of the benefits. You sort of get the best of both worlds. You get to turn it off, which is, longevity promoting and decreasing your risk of cancer, because you're taking this time for autophagy while you sleep. That 12 to 14 hours of no food, right? No late night snacks. And then between meals, you're also letting mTOR get turned off, which also allows for autophagy once again, and the cellular housekeeping, the cellular cleanup, which is so important. So I hope that kind of makes sense. mTOR is not the devil. mTOR is life. mTOR is just one of these things that turns on whenever there's growth happening. And we want it to be on to be able to grow our muscle, to get strong, to get buff. So we have that ability, and we don't have to get buff, but just have that functional ability to do what we want to do in life. We've got to be able to get up out of our chair. Hopefully we can go for a walk. Hopefully we can pick up our groceries or pick up our grandkids or whatever. And in order to be able to build that muscle mass, we need to have mTOR turned on from time to time when we eat a good meal. So anyway,
welcome to
I hope this helps. I hope you guys got some benefit here. It's been a lot of fun sharing it for you. There's so many more things I want to share, but I try not to get these too long. I don't want you to get caught up in the weeds of all this, because literally I could talk about mTOR for an hour, 2, maybe 3 hours, because there's so much out there. I think there's a lot of confusion, but it's really pretty simple. So if you didn't quite get it, just go back and re-listen. I explain it pretty simply. It's a natural process. We just don't want it going 24/7. We want to have some breaks in the action of our mTOR while we do our intermittent fasting, while we do our time-restricted feeding, or our breaks between meals. So that way we get the best of both worlds. So I hope that's been helpful for you. I hope that's been beneficial. I've really loved sharing it with you. Please share this podcast if you feel like it'll help anybody you know, family, friend, whatever. Ask them to also write a review. And hey, they'll also have a chance to get a free course on natural healing, natural weight loss, natural health, through all these good natural means that we've talked about in the show, and much more. You can get a PDF to go along with it that helps you set goals, that helps you just put the so-called the rubber meets the road, when you actually do stuff. Because learning is great. Learning is not really power. It's sort of the potential power that Tony Robbins talks about. We got to then actually do something. We got to put our pen to the paper. We got to make some goals, and we got to keep ourselves honest. Grab a partner, somebody that you can be accountable with, and do it together. You guys each grab the course. Maybe one of you can get it for free by writing me a review, or you can split, whatever. But grab the course, do it together, get healthy, lose weight. You notice I said it in that order. Get healthy first, and then the weight will come off. Anyway, it's been such a pleasure, guys. Love you. I really appreciate you, and can't wait to share with you on the next show. So until then, a big aloha.